Okay, folks, today we're going to start learning our exponent rules, which we will learn more exponent rules tomorrow, and then on Wednesday put it all together. So let's go over some basics real quick. First of all, exponential form. Remember, an exponent is the little number that is superscripted, and it tells us how many times to multiply a number by itself. The base is the large number that is to be multiplied by itself. And when we say exponential form, it's where we take that base and actually write it raised to that exponent. So for example, 2 to the 5th is equal to 2 times 2 times 2 times 2 times 2, which would be 32. When we write the part where we expand it out, and like where we say 2 times itself 5 times, that is called expanded form. Okay, so let's look at a couple of original products, their expanded form and their exponential form. So if we have 2 squared times 2 to the 4th, and we write it in expanded form, we can see that we are actually multiplying 2 by itself 6 times. So to write that in exponential form, to write it as a single power, that would be 2 to the 6th power. Check out the next one, 5 cubed times 5 squared. When we write it in expanded form, we're multiplying 5 by itself 5 times, so that would be 5 to the 5th power. X to the 4th times x to the 7th. When we write it out, we can see that we are multiplying x by itself 11 times, so that would be x to the 11th. Wouldn't it be nice if we had a rule that we could use for when we multiply like bases, because that's what we're doing right here. These bases are the same. What could we do with these exponents so that we didn't have to write it in an expanded form? And as you can see, it's quite simple. When we multiply like bases, we need to add the exponents, and that's where this rule comes from. The good thing about learning the expanded form is if you ever get stuck and you can't remember what the rule is, you can always go back to expanded form and figure it out. All right, so just a little review of some terminology. First of all, a monomial. A monomial is a number, a variable, or the product of a number and variables. And that's what we're going to be working with over the next few days, is multiplying and dividing monomials. A constant is a monomial that is just a number, no variable. And a coefficient is the numerical factor of a monomial. All of the problems that we're going to be working on, the directions will say to simplify. So what does that mean when it says to simplify? When you have an expression that is simplified, there are no powers of powers. Each base appears only once. All fractions are in simplest form. No parentheses are left in the problem. And we only have positive exponents. We will keep referring to this as we go through our problems. All right, so let's start with the first rule that we just discussed. This rule is called the product of powers. And what it tells us is when we multiply like bases, we add the exponents. So if we have a to the nth power times a to the nth power, because a and a are like bases, this would become a to the m plus n power. All right, so let's look at this first example. The big thing that you have to remember is that you're going to multiply your coefficients like you've always multiplied. These are not exponents. So 3 times 2 is still what 3 times 2 has been since you were in 3rd grade. 3 times 2 is 6. And then you multiply like bases. So we have x squared times x. And even though you don't see it, that's really x to the first. So x squared times x to the first would give us x cubed. 2 plus 1 is 3. And then we have y times y cubed. So again, even though you just have this y by itself, it's really to the first power. So we now have y to the 4th. And then in the end, we have this z squared we're just going to tag on. So our final product would be 6 x to the 3rd, y to the 4th, z squared. All right, why don't you get a sheet of paper, pause the video, and try the next 3 problems. Okay, so looking at the first one, x to the 5th times x to the 4th should give us x to the 9th power. When we look at this, even though it's weird, we could use order of operations and work it out as we go, or we can use our exponent rules. -3 and -3 are like bases. So since they're like bases, we can just add these exponents. So that would be -3 to the 5th power. And then we could actually multiply that out to figure that out. If you did not have a calculator, you would just think about it. If you multiply a negative by 5 times, because it's an odd number of negatives, our product would still be negative. And then you would just kind of use a little multiplication tree. So if we have 3 to the 5th power, 3 times 3 times 3 times 3 times 3, we know 3 times 3 is 9, and 3 times 3 is 9, and then we still have this 3 here. 9 times 9 is 81, and then we still have this 3 from over here. And then if you thought about 80 times 3, that would be 240. 1 times 3 is 3, so this would come out to be 243. So our final product would be 243. You can also use Desmos. You can type right into Desmos like a normal calculator, and you could come right here and just type in -3, close parenthesis, raised to the 5th power, and look over here and you can see that it gives you -243. All right, and then for the number 3, m to the 3rd times m to the 7th. Remember, this m right here is really like m to the 1st, so 3 plus 1 is 4, and 4 plus 7 is 11, so we have m to the 11th. Okay, now on your sheet of paper, copy down the next 3 problems. Try them, pause the video when you're done, turn the video back on to see how to work them out. Okay, so for number 4, we have 4 to the 4th power times 4 to the 8th power. If we use our exponent rules, we add those exponents. So that gives us 4 to the 12th power. And if you actually put that in your calculator, that would give us 16,777,216. Of course, you would never have to multiply that out on your own. A cool thing about checking that out with your calculator, I'm going to pull this up real quick. You can actually, because since it's just numbers and no variables, you could type in the original product and then type in when you condensed it in exponential form and make sure that it's the same to check yourself. All right, for the next one, we should have m to the 4th, n to the 6th. And then the last one, if we did it with exponent rules, 2 squared times 2 to the 1st is 2 cubed. A to the 1st times a to the 4th is a to the 5th. And then 2 cubed, that's 2 times 2 times 2. So 2 times 2 is 4, and then 4 times 2 is 8. So that gives us 8a to the 5th. Or you could work them out separately. 2 squared we know is 4, so that's 4a to the 1st. And then we have times 2a to the 4th. 4 times 2 is 8, and then a times a to the 4th is a to the 5th. All right, going on to our next rule. Okay, this rule says a power of a power. When we raise a power to a power, we multiply the exponents. Okay, so the difference here is, guys, we're not multiplying like bases. We're raising a power to a power. But let's understand why that happens. Going back to our rule about multiplying like bases, if we have x squared raised to the 3rd power, let's put that in expanded form. Doesn't that really mean x squared times x squared times x squared? And then if we go back to our rule about multiplying like bases, we know that when we multiply like bases, we add the exponents. So 2 plus 2 plus 2 gives us 6. So this becomes x to the 6th. But to be able to skip that step and not have to do this expanded form, we just learned the rule that when we raise a power to a power, we multiply the exponents. 2 times 3 is 6. So let's look at this one. This one would have been 4 times 2 is 8. And then we would have evaluated 2 to the 8th power to be 256. Again, this is when you could also use order of operations and work your way inside out. We could have said, okay, well, 2 to the 4th raised to the 2nd power. 2 to the 4th is 16. And then 16 squared is 256. Either way will work. Okay, let's look at these examples real quick. So the next rule is power of a product. When we raise a product to a power, we distribute the power. We're still multiplying the powers if there's already a power there. So if we have ab raised to the nth power, that is a to the nth, b to the nth. So let's look at this first example. So this would be 4 squared y squared. And then, of course, we would always simplify it. We know 4 squared is 16y squared. Looking at the next one, 2/3 p cubed. So what that means, guys, is we want to do 2/3 cubed p cubed. Whenever you raise a fraction to a power, you just raise each part of the fraction. Like the 2 is like a base and the 3 is like a base. So that's really saying 2 cubed over 3 cubed p cubed. And then if we work that out, 2 cubed is 8, 3 cubed is 27 times p cubed. And that would be our final answer. All right, and then we have our last one here. So if we distribute that power, that's 3 cubed, x cubed. But when we get to the y, there's already a power there. So that's where we have to use the rule that we just learned. When we raise a power to a power, we multiply our exponent. So that's y to the 6th power. And then, of course, we always want to clean up our coefficients. So that would be 27 x cubed y to the 6th power. All right. Use your sheet of paper and write down the next couple of problems and try them out. Pause the video. When you're done, replay the video to make sure you did them correctly. So for number 1, we have 2m to the 3rd power. So that's 2 cubed, m cubed, which ultimately would be 8m cubed. For number 2, make sure you're careful about that negative right there. We want to make sure we square the negative with the 3. So that's negative 3 squared. 5 times 2 is to the 10th power. 7 times 2 is to the 14th power. And then think about it, guys. A negative 3 squared, that's negative 3 times negative 3, so it's positive 9. Anytime we raise a negative number to an even power, it's going to end up being positive. Anytime we raise a negative number to an odd power, it's going to end up being negative. All right, and then the third one over here, power to a power, we distribute. So 2 times 5 is 10. 4 times 5 is 20, and then don't forget this 2 in the denominator. Now that 2 is not an exponent, it's a base. So we don't say 2 times 5, we say 2 to the 5th power. The only thing you should ever actually multiply would be an exponent and an exponent, never a base and an exponent. So if we work that out, that is x to the 10th, y to the 20th, all over 32. But you may also see it written where they put the coefficient in the front. Dividing by 32 and multiplying by 1 over 32 is the same thing. Okay, last rule for today is the 0 power rule. Anything raised to the 0 power is 1. This is kind of confusing. It's a hard rule to really understand, but let me kind of just show you a little pattern real quick that might make it make more sense. If I looked at a pattern of numbers, if I had 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st power, and 2 to the 0 power. Well, 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. So what is 2 to the 0 power? Well, if you look at this pattern right here, 16, 8, 4, 2, what you notice is that each time we go down by one exponent, we are dividing by 2, or we're halving the previous term. So if we get right here to 2, 2 divided by 2 is 1, not 0. So maybe that'll kind of help you, and you could look at a bunch of them and you would see the same thing happen over and over again. Okay, look at it with powers of 3. So if I have 3 cubed, 3 squared, 3 to the 1st, and then 3 to the 0. 3 cubed is 27. 3 squared is 9. 3 to the 1st is 3. What is the pattern when we just look at the numbers? 27, 9, 3. You're dividing by 3 each time, which makes sense because here you were multiplying 3 times 3 times 3. This is just 3 times 3. This is just 3. So if I have 3 to the 0 power, when I divide by 3 again, we're at 1. So ultimately, anything raised to the 0 power is 1. All right, so looking at this problem right here, this is a monster problem. This is the only time I tell students not to follow order of operations. It does not matter what's inside this big old parentheses, as scary as that is. The whole thing's raised to the 0 power, so our answer is 1. However, when we look at this little problem over here, the only part that is being raised to the 0 power is the x. So that is the only part that is equivalent to 1. Therefore, this is really saying 2 times 1 times y cubed. And 2 times 1 is just 2y cubed. A lot of times what I do if I'm in the middle of a problem and I just see something raised to the 0 power, I just kind of scratch it out like it's not there because it's really just multiplying by 1 and anything times 1 is itself. All right, let's look at the next page. what I would like for you to do is take your sheet of paper and write down these problems. First, I want you to start with just A through C. Once you have done A through C, we will go over them. And then I will do D with you, and then I'll let you try E through G. So go ahead, write them down, pause the video, and try A through C. All right, so for A, sometimes these are written with parentheses, which is confusing, but it really just means multiplication. So if you need to just rewrite it with multiplication, we should have gotten A to the 9th. The next one, -5 times 2 is -10. M cubed times m to the 9th. We're multiplying like bases. Add those exponents. That's m to the 12th. N to the 1st times n cubed is n to the 4th. And then the last one, even though you don't see it there, that's really like having a 1 in front of here. So 7 times 1 is 7. A to the 5th times a to the 4th is a to the 9th. B squared times b cubed is b to the 5th. All right, something I want you to realize is that you have to make sure you're doing when you do these order of operation, these exponent problems, is always follow order of operations, except for when it's raised to the 0 power. That's the only time I would ignore it. So make sure you are taking care of your exponents before multiplication and division. So let's look at this next problem down here. All right, in this problem, what makes it different from the problems that we just did is this is not being raised, this first expression right here is not being raised to a power, but this second one is. So we have to make sure we take care of this monomial being raised to the second power before we multiply, because we always do exponents before multiplication. So what I'm going to do right here is I'm going to write down the first monomial, -15xy cubed. And then I'm going to go ahead and square this one. Now, when we do the -1/5 squared, if you need to, just go over to the side of your paper. You're saying -1/5 raised to the second power. Guys, remember, when you raise a negative to an even power, it's going to become positive, because that's really like saying -1 times -1, which is +1. And then 5 squared is 5 times 5, which is 25. So right here, that's going to give us +1/25. And then we distribute the power. So that's x squared. Since there's already a power here, power to a power we multiply, that is y to the 4th power. Now we can multiply these two monomials together. Again, if you need to go over to the side of your paper, -15 times 1/25. I like to cross reduce. 5 goes into 15 3 times, so that would be -3. 5 goes into 25 5 times. So ultimately, this would give us -3 times 1, which is -3, over, and this is really like over 1. 1 times 5 is 5. So we get that this is -3/5. X to the 1st times x squared gives us x to the 3rd. And y cubed times y to the 4th is y to the 7th. And that would be our final product. All right, pause the video and go ahead and try E, F, and G. Okay, so this first one, you could notice that we've got some powers in here, so we have to make sure we take care of those powers before we multiply. So I've copied the first one. The next one, I've distributed that power of 3, so that's 2 cubed, 8 cubed. 2 times 3 right here is b to the 6, c cubed. And then ac cubed is a cubed, c cubed. Then I cleaned it up, and the only part I really had to clean up was this 2 cubed right here, so I went ahead and made that into 8. And then I multiply. 3 times 8, and there's really like a 1 right here, is 24. A to the 1st, a cubed, and a cubed, I add those up. 1, 3, and 3 is 7. B squared, b to the 6, no b's here, so that's b to the 8. And then c cubed times c cubed is c to the 6. Looking at the next one, you can see I did the same thing. I broke it up and did each part and their powers, and then worked it out and multiplied it. And then the very last one would be 1. You now have a small assignment to complete in Delta Math. I'm making the assignment small since this lesson was kind of long, but then on Wednesday, we'll put it all together. So we're learning a little bit of a lesson today, a little bit more tomorrow, and then Wednesday we'll put all these rules together. Good luck, and if you have any questions, you can Zoom with me during my office hours.